Dear students, today we are going to talk about yet another important topic which is called projectile motion. So all of you have studied one-dimensional straight line motion, so that's pretty much straightforward. But when it comes to projectile motion, many students just don't understand how to apply equation of motions and all those things. So this is where I thought let me make a video and try to help you out. How do we use those equation of motion and what actually the projectile motion is and what are the important terms and terminologies used in projectile motion. So let's get started with the video. So the first thing I want to explain is why it is called a projectile motion. So you can see this picture here. I have thrown a ball. Basically, if you throw a ball at an angle theta, this is angle theta, you can see, and ball is thrown with the velocity u at an angle theta with the horizontal plane. This is horizontal plane along x-axis. So let me make this thing over here so it will be very much clear. So this is your horizontal plane and you throw the ball or object like this at an angle theta. This is your angle theta. We are not throwing it vertically up or horizontally. So we are throwing at an angle theta with initial velocity u. So what do you think? How this ball will go? So some of you might think this ball might go straight like that, right? But actually this can go straight if there is no gravity. But due to gravity, this ball or this object will continuously be pulled down. So there will be a force due to gravity which will be continuously acting on the ball or the object. So because of which the path it will take, it will be like this. So it will go up to certain maximum height and will take a curve, this kind of curve, and it will start coming down slowly like this due to gravity. So it won't go straight like this. I hope this is clear. So because of the gravity, it doesn't go straight like this, but it comes down like this. So the path is like this. This kind of path is called a projectile path. We are projecting the object at an angle theta, and this path is called projectile path or trajectory of the path. Trajectory. Okay? Trajectory. This is called trajectory of the path or projectile path, and this angle is called angle of projection. Angle of projection. Angle of projection. So during this entire process, what is happening? This object starts its journey from this point and reaches at this point. So it is traveling certain range. This distance is called range. Okay, and it goes up to certain maximum height. So this is called height maximum height of the projectile, and during this entire flight of the projectile, it takes certain amount of time. So that time is called flight time of the projectile. So there are certain terms associated with projectile motion, which are basically range of the projectile, flight time of the projectile, maximum height of the projectile, trajectory of the projectile. So these things you have to remember, and we have to basically derive these values. So as I said, we have to derive the values of height max, range, flight time, and even the formula for the trajectory. What is the equation of this trajectory? Okay, so we'll work towards the derivation. So just give me some time for that also. So I have written the formula, like for flight time it will come out to be 2t is equal to 2u sin theta by g, R is the range, R will be u square sine 2 theta by g, and height max will be u square sine square theta by 2g. So these are the three parameters for the projectile motion, and trajectory equation I will do later on. So let's look at this picture which I have drawn already for better understanding and better clarity. Here what is happening? The projectile is projected at an angle theta with the initial velocity u. You can see over here, this is the projection angle, and it is going like this. Initial point is A, and it's going from point A to B and point C. B is the maximum height. So at point B, there is no vertical component of velocity, because that is the maximum height. Why there is no vertical component of velocity? Because at when anything goes up, at maximum height when it reaches, velocity becomes zero. The vertical velocity becomes zero. That is why there is no vertical component of velocity, only horizontal component. But before that or after that, before point B or after point B, there are both component of velocity. You can see here at this point we have both the components, horizontal as well as vertical, and here also horizontal as well as vertical. So this thing you have to keep in mind. But the direction of vertical component, you can see they are reversed here. Before B, it is going up, ball is going up, or the object is going up, so vertical component of velocity is upward. Here ball is coming down, so your vertical component of velocity is downwards. Okay. Now coming to point A, at point A your velocity is u in this direction. So what will be the component of velocity in y direction? We know that we have studied those things in vector components. So it will be u sine theta along y axis. Along x axis it will be u cos theta. Fair? Now we also know that when it is going upward, what is the acceleration in y direction? It is minus g. It is going against the gravity, right? So acceleration due to gravity is g. Then since it is going against gravity, acceleration will be minus g. And what is the acceleration in x direction? There is no acceleration in x direction, so it is 0. So it is going without any acceleration, uniform motion. Velocity is uniform, so u cos theta remains unchanged. So the velocity of a ball at point A in x direction is same as what we have at point C. Here also will be horizontal velocity will same, it will be u cos theta at point C also, because there is no acceleration, no change in velocity. So far so good. Now let's see. When it comes to the equation of motion, we all know that those equations can be used, like v is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Those equations we can use when acceleration is uniform and the object is traveling in a straight line. We cannot use for this kind of parabolic or this kind of trajectory. So what do we do in this case? We have to break down our motion in a straight line. Then only we can make use of those equations. So how do we break down the motion in straight line? So that is where we have broken down this velocity into components, in x direction motion and y direction motion. So y direction motion component is u sin theta, x is u sin theta, u cos theta. So that is where we are going to use our velocity equations. So fine. Now for the y direction motion, for this entire motion, we know that the displacement in y direction is how much? Displacement is in y direction. displacement, y direction is net displacement is 0. It goes up and comes down. It starts from point A, goes up to point B and comes down to C. It displaced in x direction, but in y direction there is no displacement, right? So y direction is displacement is 0. Now we can use the equation of motion, which is s is equal to ut plus half at square. This equation we can use, where we can put displacement s is equal to 0, y direction initial velocity, use initial velocity, y direction initial velocity. We have to put y direction initial velocity because we are going to use y direction displacement. Okay, so y direction initial velocity is how much? U sin theta. So when it goes up and comes down, so that is the time taken t is what? The total time in travel. So that is your what? Flight time. T, capital T, plus half A is what? It's going against gravity, right? Minus G and T square. Which means we can take T as common out here. U sin theta minus g t by 2 is equal to 0. Out here we get, so this is what is your flight time. Okay, because t cannot be 0, right? So this is first thing we have derived, 2u sin theta by g. So you all understood how we can break down this motion into straight line motion and use the equation of velocity equations and find out the values of the respective parameters. So this is how we found out the flight time. Now we'll move on to the next parameter, which is range. How to find range? So just now I mentioned in x direction there is no acceleration. So x direction displacement or total travel distance will be what? Velocity into time. Simple as that. We know that we have studied that even in grade 9 when distance is equal to velocity speed into time. So range will be simply range r will be u cos theta into total travel time, total flight time, basically flight time, because there is no acceleration in x direction. We are taking this thing in x direction now, x direction. So u cos theta, and what is the flight time we just now derived? 2u sin theta, 2u sin theta by g. This becomes u square 2 sin theta cos theta divided by g, and this we all know is sin 2 theta. This is the expansion of sin 2 theta. This can be written as u square sin 2 theta over g. This becomes your range r. So this is your another formula for the range. Clear? Next is height max. This is also pretty much simple. So for height max, what is the equation of motion we can use? Again we have to go into vertical direction, which is y direction, because we have to find this y value at point B. At point B, what is the velocity? Vertical velocity. Because we are starting with vertical initial velocity, which is u sin theta, vertical final velocity we have to find here. Just now in the beginning of my video, I told you vertical velocity at point B will be 0 because that is the highest point of the projectile. At any highest point, when you throw any object up in the air, at highest point velocity becomes 0. So vertical velocity at point B, we know that it's 0. So we can use this equation v square is equal to u square plus 2as. This is the equation we are going to use. V is final velocity, u is initial velocity, a is the acceleration, s is the height or distance traveled in y direction. So v is final velocity which is in y direction, which is 0. U is initial velocity in y direction, which is u sin theta, plus 2. A is acceleration of the object in y direction, which is minus g. S is h max, correct? So using this we can get the value of h max. So h max comes out to be u sin theta over 2g. So this is what, I'm sorry, it should be u square sin square. I forgot to. So we get u square sin square theta over 2g. So this is your h max formula. So these are the three major parameters for the projectile motion, and this is how we derive the values for height max, range and flight time. The scenario what we have considered here is the object is projected from a flat surface at an angle theta with initial velocity u, and it's returning back on the same surface. So you should remember that you cannot directly use this formula everywhere in all the cases. These are not generic formula for projectile motion. It's not like anywhere in any of the problem if you see projectile motion is happening and you just start using this formula. No, it doesn't work that way. You have to look at the case scenario. In this scenario, the object is projected from a flat surface with initial velocity u at an angle theta, and the object is coming back to the same surface. So there might be many cases where question can be like this. This is your flat surface. There is a building like this which is of height h. Building's height is h. Object is projected from top of the building, maybe like this. Then it will go like this and come like that. Here you cannot use these formulas because this building is already raised at an height h from the ground. So in that case you have to derive your own equation for projectile motion, flight time, range, height max and all those things. But the methodology or method of deriving these parameters will remain same. The intention behind this is to make you understand how do we convert the motion in a plane in a one-dimensional motion and come up with these parameters. I hope this makes clear, and with the help of this you can derive these parameters for any kind of problem. Now the last thing about the projectile motion is the equation of trajectory. As I told you in the beginning, this path is known as trajectory of the projectile. So to derive the equation of trajectory, we have to find the locus. We all know what is locus. The students who are studying math, they understand locus better. But let's not worry about that. You don't need to understand much about locus and all those things. I just referred that thing because it relates better with locus. But even if you don't know locus, that's not a problem. I will tell you how to derive the equation of trajectory, because in some of the problems they might ask you to find out the trajectory equation as well. So what do we do for that? For those kind of problem, You have to just imagine a point on the trajectory. I have imagined a point P, and let's say this is the point P, you can see over here, and coordinates of that point are x and y. Okay, so this distance will be x on the x coordinate, and this will be y. Okay, this is y, you can see over here, and this is x. So basically we have to form an equation between x and y. That's the whole idea. What will be the value of x at? And this point P, basically the object is reaching at point P after time t. At time t. T is your variable, it can be any time. So at time t we are considering x is equal to how much? It will be, we can find this distance, right? X, travel distance on x-axis. It will be u cos theta into t, right? Distance travel in x direction, velocity into time. It's as simple as that. How about y? Y will be vertical distance. So for that we can say, we can use, let's say this is equation number 1. Y is a vertical distance. For that, along y axis, we can say s is equal to ut plus half at square. We can use this formula. S is equal to y, u is equal to initial velocity along y axis, which is your u sin theta, plus half. A is minus g, t is t. We are working in terms of t only at time t. Basically we are finding everything. So we get y is equal to u sin theta gt square by 2. This is the second equation we get. Now you look at x and y. We, as I told you in the beginning of finding this equation, we have to find the final trajectory equation in terms of x and y. How do we do that? We have to eliminate this variable t. This. So let's put the variable value of variable t from here. Find out the variable value of variable t from here and put it here. So from here, what do we get? T is equal to x over u cos theta. So let's put this value in this equation. So what do we get? Y is equal to, I missed this t. Okay, so u sin theta into x over u cos theta minus g by 2 x over u cos theta. This becomes whole square. U gets cancelled out. Now we have sin theta over cos theta, that is tan theta. So x tan theta minus g x square, g by 2 x square by u square cos square theta. So that is the equation of trajectory we get. So this is the equation of trajectory. So likewise you can find out the equation of trajectory for any trajectory of projectile motion. So this is a this is a projectile motion from a flat surface where projectile is projected from the flat surface and it's coming back there. But there could be any other scenario where it is projected from a raised surface or whatever may be the case, but you can find the equation of trajectory by a similar method. You have to assume a point x, y and find out the value of x and y in terms of t and eliminate t later on and just find the final equation in terms of x and y. That's it. That's the way we do. So I hope it is clear to all of you, and if you have any question, please do ask me through your comments in the comment section below, and I would be happy to answer you. So with this I would close this video, and I will be hoping that some questions will be coming from you guys, and that way we can initiate the discussion and it could be even more healthy. So please come forward, ask the questions and make the video more helpful, and share the videos even with your friends so they can also be benefited out of this. So see you in next video. Thank you so much.